Hey everyone, welcome to another episode of Chaos Craft. No, wait, Chaos Trainer, sorry. It's been a heck of a day. I tried doing a live stream and it did not work. So we're going to just do this instead. So, since the last time you guys have seen this, I had my level builder, I think was the last thing I might have shown. And we started running these guys to simulate. And what I implemented most recently was a system called NEAT, which is for augmented typography, typography. Either way, evolving neural nets through augmented topologies. So useful for video games and stuff of that nature, or anything where you don't have a set list of contra neat. That's cool. A set list of data to test against. You're basically creating it on the fly. And add this to my watch more. A good example of this is Mario, and I'll try and include this in the show notes here, which doesn't get into much detail about it, but something that actually gets into a little bit more detail is this Flappy Bird, FlapPyBi, which sounds like it's made by some students, but they actually did a pretty good job of explaining some of this stuff, so that was cool. So thank you guys. And so what we're looking at right now is just this little thing. I have, two species in there right now with a high score 22 and 20. That's basically the distance that they make it, like tile-wise, across here and up here. The lava doesn't count. As soon as they hit lava, it's pretty much over. And the spawn tiles don't count, so they've got to make it, We're trying to get them to see who can get to the furthest up here with this course. And you can see, I think you guys probably already saw, I've got my count controls where I can go and put 30 of them in there at once if I wanted to and have them try and go through. And you can see they pretty much die up there. I need a better die animation. Plus I should stop moving. And I could say I want them to live for 30 seconds of game time instead of let's see. So I'm giving them more. If I want to set it down to 1, they're just going to die over and over and over again. 1, 2, 3. Yeah, so I can change that up to 15 or whatever. And then here's the speed, basically. So that's at normal speed for them. And then I think I showed you guys my neural net view. And so with NEAT here, you can see my hidden layer is a little bit more simplified. Now the really annoying thing right now, and this shows you, you can, their health input is at 1, so that means that they've got 100% health. Angular velocity is at -1, so that's an input to see, like they can kind of feel, are they moving? It's at 1, I guess. So interesting. Their velocity input's at 1, so this guy's had to have died off by now. So let's go up into 30 seconds real quick. And these guys are just coming and going so quickly. You can see here his inputs are turning and his outputs are turning, and they get darker the more it's engaged. So this guy's inputs have him switching. He must be heavily determined on these two inputs there, I'm guessing. And we can verify that real quick. And this is the really annoying part, is that I can go like that in the game and I can't see the neurons, but all I have to do is hit over to here and look at that. Oh, the neurons are there. We can actually see that this guy's velocity input, affects his turn output. This guy can see, input, and I can't test these things because I can't click on this stupid menu. So it's like I got to go back and forth. All I do is get these elements there. So, but basically, if we find one that's alive and turning, ideally, doing something besides just staring there, well, I can go ahead and click view, and we can kind of see he found this one is on because he can view that little spot there. Does that kind of make sense? So you can see tile, and he must be looking for a wall tile there. So basically these guys, I gave them all 3 eyes right now for the moment. I know it looks like they only have 2 in the animation, but they can see up to three spots away. You know, up that guy died off, so it doesn't matter now. I need to make it so these guys can stay in there, but so you can see that it's looking, well, now he's dead again, so it doesn't matter. But okay, come on, come on. There we go. That's an example of his eyes in action there, trying to see stuff. Evidently some of these tiles have fallen off. Alright, I broke my own thing. You can kind of see how that's twirling there and on occasion spotting things. And the strength of the output has to do with the distance to them. So if they see it closer, the output will be higher. And you can see that goes through this hidden neuron, which then goes out there. So we don't know exactly where because that stupid line renderer is not rendering. So it's driving me nuts. And then once he dies, you can see he kind of just disappears here. Unfortunately, I need to make it so it clears and resets all the tiles back to their original colors. What was I saying? So that's a lot of what we've been doing, just working on that and the species tool, where we can track, you know, generation since improvement and a couple other things. And the other thing I wanted to show you guys, oh, yes, for anybody here getting into neural networks and stuff, I just want to make sure I'm still recording here. Yes, good. Anybody getting into neural networks and stuff from computers is that you might want to know that I had a problem where I had trouble understanding the sigmoid function. I think I understood it, but I was thinking like a programmer and was thinking from 0 to 1, which is what it flattens anything into. But what the sigmoid function I'm using wants is from -1 to 1 for the most part. So when I figured that out, this is from -5 to 5. When I figured that out, man, did that get a lot better. Because that was really annoying because I had all my nodes, you know, can see go from 0 to 1, but not from -1 to 1. So we're only getting the partial range of what these things all get flattened into. So now we have a much bigger range. We're either at like 0.99999 or 0.0001 before. It was like super annoying. So it's always on, always off, almost where you could see there's like a little bit of fluctuation here. You know, not much right now, but yes, 0.7, 0.8. So what I want to show you guys is my BrainMaker config data. So in here, there's a bunch of stuff like I can choose. I turned off memory for early generations just because I thought it added unnecessary complication. They don't need memory to solve this puzzle. It's just if there's lava, turn away from it. If there's a wall, turn away from it. Other than that, walk. It's pretty simple. Basic noise, I've got true, but that's not actually even written yet because they can't hear anything yet or communicate. But I'm planning on doing that. Input basic vision is true. Input basic hearing, that's also not written. Input basic movement, so that's like the stuff where we were seeing that they monitor their velocity and stuff. And input basic self-awareness is just health right now. At the moment, we're not using neuron dependency decay chance. When I switched over to NEAT, I'm not implementing that, nor am I using max dependence at the moment. And I turned off LSTM logic, which I should probably see what that does actually now. But what that does is feed in each neuron's last value and makes that part of the equation. And then NEAT start neuron dependent count. So this is 3. So if I restart this simulation, come on. And I'll have to go out and back in. Well, basically, there's only 3 neuron dependencies that'll show up. Unfortunately, we can't see them because Unity's line renderer tool is not properly functioning. But that is neither here nor there. I'll come back to this in a second because it looks like it's going. All right, adjusted. So these right here, these 4, I can't highlight because for some reason everything's taking forever. Adjusted neuron dependency chance. So these four right here, basically, as you notice, they add up to 100. So there's an 80% chance it'll adjust the weight of a single neuron dependent by plus 2 or minus plus 0.2 or minus 0.2. That's out of a scale of -1 to 1. Hey, look at that. It decided to load. Species. Oh wait, I want to show you guys their neurons. So the generation 0, which this guy is, they have 3 dependents. Okay, so basically this turn output is a factor of angular velocity input, and if they can see this tile, I should probably put like a little more information which eye it is and what tile it is out there. But if one of their eyes can see some tile, and depending on how close that tile is to them. So, and then this move output is just a factor of their velocity input. So if they're not moving, they're probably not going to move. So this guy's probably not going to make it too far. All right. So either what I was saying, or yeah. So there's an 80% chance we're going to increment the weight by plus or minus 0.2. Then here there's a 10% chance that we're just going to assign it a brand new weight in between -1 and 1. Over here we might add a new neuron dependency. So that's like this neuron would be, now dependent on that neuron there. And then over here there's a 5% chance that we're just going to add a whole new neuron. So what we usually do is we just put it in between an existing neuron. So we might just put in like a hidden neuron there. And that's just a 0.5% chance of that. Now down here is all my fitness stuff. Use global fitness basically says that we can either take the fittest of all time, like, so it could be a Gen 2 and we get all the way up to Gen 8, we haven't seen an improvement. Well, it'll use that Gen 2 as its blueprint, as like the best one of sorts. It sounds weird when I say it, because it's still using a lower generation, but if we have this set to false, it'll always use something based off of last generation, even if it's worse than the previous generation. It forces evolution. This is why these are settings, because we're going to play with them. I'm going to give you guys the ability to, like, a UI to change all this stuff and set it and do whatever. Max spawn count per generation. That means, we run 100 guys, and right now there's only 2 species, so basically each of them is going to get roughly 50 of them. Each generation. Then after that we try and up it. Now, do I actually run it with 100? No, I run it with 1,000 usually, and then we use the top 10% of that, so we'd save 100 of that generation and try them. These are numbers again I'm playing around with, but I dropped it down to 100 a lot of times for when I'm just doing like regular simulations and stuff to make sure that the generation ticker is ticking and everything like that. Max generation since last improvement, that means that if there's a species and it hasn't improved in a while, then max generation since last improvement, that means that they're kind of at a standstill. And right now I've got that set to 100 because I was running a simulation last night. I wanted to give them extra time to try and evolve. But usually it's probably a little bit lower, because if they haven't gone 20 or so, then we probably want to move on and try a different species. Minimum species count usually is a lot higher than 2, but I just wanted to test some stuff last night, so that means that is the... Come on. You make that maximize button less hidden. Hold on, I got neuron view, species view. All right, so this is, like I said, this is a species right here. The species has been around for 2 generations. As of them, because they're both 0 and 1, they're the first 2, and this guy hasn't improved generation 1 evidently. And a high score of 6 is not very high. I think 30s is a pretty decent score. That's when you really start seeing that they've made some intelligence at that point. So speaking of, you guys probably want to see them cranked up and... What is this? You guys probably want to see them cranked up and evolve. Unfortunately, with the settings I have right now and the way it's set up right now, we're not going to see much because I'm in test mode, but I will happily do one at another time. So I'm trying to think if there's anything else I wanted to show you guys. I did show you guys the bot vision thing already, which I think is one of the cooler things about this. So you can see... Nope, that bot's dead. Dude, that bot's gonna die. See that there? That's him looking. Why are those not? Those should not be staying marked red. I gotta go back and see why those are getting stuck as red. You can see it's like basically his line of sight is the red ones, and then the green one means that it matches. And if the closer it is, I should make the brightness of the green equivalent or somehow equate to how bright it is, or how how close it is for the score, because these are all based on this is one that's 0.75. If we were to somehow be able to zoom in, we'd be able to see that that's darker. But either way, I got a lot more work to do. Those lines not drawing are killing me right now. So if anybody knows anything about Unity there, let me know. If anybody knows anything about machine learning and is an academic and would like to chat about this, I'd love to chat with you. I think I'd love to see if there's any way I can improve this. One thing I haven't started doing that they advocate in this is actually cross-breeding them, and that should speed up the process significantly of these guys learning too. I have implemented innovation numbers from this. Yeah, here, this is a really good paper. I'll try and include this one as well in the show notes. But yeah, the innovation numbers, which this shows you how to mutate and breed, kind of. I haven't done the cross-breeding yet, so I've got to figure out how to do that one. But we'll get there, all in good time. With that said, I think I'm going pretty long here. What have we been going for? 16 minutes? Well, I think I'm going to let you guys go, and let's see, I'll leave you guys with my usual, I guess you could check me out on Twitter too. I guess I am starting to do more Twitter stuff with this, and I'm pretty sure I'm at Schematical. Let's find out. Yep, at Schematical, and of course, jump on the conversation on Discord. We've got some really cool stuff going on here. Really cool discussions. So thank you everybody that's already on Discord. And thank you, what was it, Dr. AV001 for some kind words of encouragement when I was tearing my hair out last night. And Salmon Red and Super Jerry and everybody else, Blizzace, for your financial support on Patreon as well. So thank you guys. Take care, and until next time.